Hi, I'm Michael Bergen. I am the VR Global Alliances Manager for NVIDIA, working on some wonderful content around variable rate shading to increase the performance and visual acuity of VR. So variable rate shading is a way to keep your frame rates high and your quality high. In order to keep VR compelling, you have to maintain a frame rate of about 90 frames a second. On the other hand, you want to make sure that everything looks great. So it's the trade-off of quality versus speed of rendering. We accomplish that by using variable rate shading. So variable rate shading is a way that you can take each pixel, which is each green dot there, and render it either up to as coarse as 4 or 8 pixels per one shader, all the way down to 1 shader per 1 pixel. We can also invert that and super sample by putting more than 1 shader per pixel, 4 shaders a pixel, 8 shaders a pixel, for super high quality. But we don't need to render the entire scene in high quality, just the parts that you're looking at. In order to do that, we have 3 different modes of variable rate shading: lens optimized shading, foveated rendering, and content adaptive. Lens optimized shading puts the highest quality render in the center of the lens, where the user is generally focusing and where the lens focuses the most content in the highest resolution. And as the lens shape tapers off, we can reduce visual acuity to spend your rendering time and your rendering pipeline on the core of the lens. We can also use foveated rendering. This HMD is the HTC Vive PRO Eye, which has Tobii eye tracking built into it. So we can actually look at where the user is looking and render where the user is looking, the fovea, in the highest possible resolution, and let the parts not in focus render at a lower resolution. And finally, we have content adaptive shading, where we can take a texture or a mesh or a part of the screen and say, no matter what happens, render that in the highest possible quality. So for example, I have a carbon fiber hood on this car, and if I want to make sure that carbon fiber looks great no matter what, I'll say, don't use foveated rendering for the carbon fiber hood, only use content adaptive shading. Make that look great no matter what. So if somebody was in VR, if you focus the camera on here, what you'll see is, to look at the car, you can see there's moire patterns on the carbon fiber. As we increase the shading, it gets higher quality. However, when you go 1-to-1, it's actually lower quality because it's such a high frequency texture. So we can super sample, and at 2 shaders per pixel, it's very smooth. 4 shaders per pixel, it's even better. And at 8 shaders per pixel, it is essentially photorealistic. The second of 3 parts of this demo, second of 3 parts, is inside the car. And so what we're looking at here is 8 shaders per pixel, super sampling. And if you look, you can see the console is very clear. The numbers are very clear. Sorry, we just lost tracking because you're standing in front of the sensor. There we go. But the visuals are very clear. But if you look at the bottom of this gray here, you'll see we have a lot of reprojection. So we're using a lot of dropped frames, and we're at 45 to 50 frames a second. Turn on foveated rendering, and we have no reprojection. Frame rate's gone back up to 90, and we still have that same very high quality. You can read the text, and you get very high quality VR using foveated rendering. So same high quality, super sampling, you get some reprojection and slow frame rates. Foveated rendering, you get high quality and high frame rates. The third and final part of the demo is to show the content adaptive. Unfortunately, not being in VR, actually you can't see it on the screen. The center part is where the eye is facing, and you see that's nice and smooth, but outside the foveation region, the carbon fiber hood looks like it's got some moire patterns. If we turn on content adaptive shading, the hood looks great no matter what. So no matter where the user is looking, the carbon fiber is very smooth. Turn it off, and you can see the foveation lines. Turn it on, and that carbon fiber hood looks great no matter what. So that's a demo of lens optimized shading, foveated rendering, and content adaptive shading for VRS.